Hello everyone and welcome to another video. Today we will present you something about large signal diode. How is it working, how it looks like, what are its parameters, where I can use this type of diode. These are some questions for which you will find the answers in this video. Before starting this video, please support us by clicking on subscribe button and leave us a like. In the previous video, we spoke about small signal diode, but despite the fact that these two types of diodes have the same symbol, similar shape of package, similar material components and similar voltage drop on them, they are different from each other when we speak about parameters and the use in applications. Let's get started with the parameters. The large signal diodes have a larger p-n junction in comparison with small signal diodes, which results parameters with higher values. To be more exact, let's have a look in some datasheets for some parameters. One for small signal diode, 1N4148, and one for large signal diode, 1N5408, so we can compare them. Looking at VRRM, repetitive peak reverse voltage, this is maximum 100 volts for 1N4148 diode and 1000 volts for 1N5408 diode. Also, if we look at IFSM, forward surge current, it is maximum 2 amps for 1N4148 diode and 200 amps for 1N5408 diode. And the list can continue. These were just some examples, but the large signal diodes can have a forward current up to several kiloamperes and reverse blocking voltage up to a few kilovolts. Despite having these large values, this type of diode has a big disadvantage. It is not suitable in circuits which is working with frequency above 1 MHz. The large signal diodes are also named rectifier diodes because they are used mainly in rectification circuits. Of course that we could also use small signal diodes for rectification, but when we need to rectify a signal in applications with more power and current needed, let's say more than 1 amperes, then we have to use a large signal diode, because if we don't do that, then our diodes will be destroyed due to overheating. And to add a little remark, most of rectifier applications require at least a current consumption of 1 amp. Further, we will go very shortly to some examples of circuits, but we will also explain each example separately in details in other videos, so keep an eye on our channel. As the name suggests, rectifier diode, these diodes are used in rectifiers. A rectifier is an electronic circuit or a device that converts alternating current in direct current. Rectifiers that are created with diodes are named uncontrolled rectifiers and can be of two types. Half-wave rectifiers. This is the simplest rectifier and converts only the positive half cycle from the AC signal in DC signal, and the negative half is blocked. For obtaining a more stable DC signal with a lower ripple voltage, we need to use a capacitor connected to the circuit output. Full wave rectifiers. This type of rectifier uses 4 diodes. 2 of them are connected in series and are used for converting the positive half cycle of AC signal, and the other 2 diodes are also connected in series for converting the negative half cycle of the AC signal. Finally, at the output is connected a smoothing capacitor, and in this way we will obtain a DC signal more stable and with a bigger capability than the signal obtained from the half-wave rectifier. In addition to this, This type of diodes are used in inverters, which are devices which can convert DC signals into AC signals and can also be used as freewheeling diodes. This was all for this video. We hope that this information was helpful and be prepared for the next video.